Often we hear time series forecasting. What is it? Well, it is nothing but some statistical method that helps us predict future values by analyzing some patterns, some historical data that's been collected over time. So what are some of the applications that we see? Well, stock market prediction, that could be a forecast. Temperature prediction in different areas, that could be a forecast. GDP, some sort of value, export and import, that could be a forecast. And also sales of houses, cars, that kind of stuff could all be part of forecasting. Some core characteristics of forecasting would be it is some collection of data or quantities. It has to be assembled over equal intervals of time or temporal order. And it also has to be chronologically ordered. And typically a time series forecast, when we look at the chart, has values that we're predicting on the y-axis and the time on the x-axis. So let's look at a stock that is quite common and popular these days, Nvidia stock. On y, you see 1000 all the way to 0. That indicates the value of the stock. And then you also see time from 2020 and beyond all the way to 2024, and you see a chart. Well, it has a bunch of things here. First, it is collection of quantities or the stock value. It is assembled over time, so meaning from early 90s all the way to 2024. It is also ordered in sequence. 2020, 21, 22, 23, and so forth. And again, x-axis carries the time element and the y carries the quantity. So for anything to be time series, amongst many other characteristics, these are the four characteristics that absolutely has to take in place. So, these are some of the examples. House prices in the United States, median house prices. Again, it has quantity on y and time on x. Look at the daily temperature of Toronto. Again, it is ordered now by month here from January all the way to December in equal intervals, obviously. And also, you can also look at from a yearly point of view. So here we have two charts that are on a yearly interval, and the one on the right is on a monthly interval. So let's look at an example. Is this time series given our 3 or 4 characteristics that we defined? When we look at the data, it has no time element. Hence, this is not a time series data. This cannot be made a time series forecasting. Once again, time series forecasting requires you to have time element. It could be a day, it could be months, it could be quarters, but it has to have temporal characteristics. Second one, it does have time, 21, 20, 22, and so on. But looks like 22 is repeating. A few times, 20 is repeating. Once again, although it has time element, it is not at a fixed interval. Hence, this is also not a time series data. Next one, looks like there are 2024 repeating again, but you see March 1st, 2nd, 3rd, 4th, and 5th in an equal 24-hour interval. So March 1st, the temperature is 15, all the way to March 5th when the temperature is 20. Looks like there are evenly spaced time-wise. It is also chronologically ordered from, March 1st all the way to March 5th. And it has time element. Looks like this data, albeit what small number of rows, is suitable for time series forecasting. So if you wanted to forecast the time or temperature of March 6th, this data would give you some historical pattern for you to use different kind of algorithms for time series forecasting. Once again, temporal data has to have time element, has to be ordered, and has to be spaced at an equal interval. If this data had 2 entries for March 1st, this would not qualify as a forecast. Conversely, if you had a lot of longer data points, you could also go by monthly, quarterly, yearly, and so forth. But the rule is it has to have a fixed interval. Let's look at this example. Perhaps you see this at your work. And this is imaginary data of company X, where on the left column you see day, in the middle you see product 1, Apple, and profit 1 corresponds to product 1's profit or loss. Negative indicates loss. Positive numbers indicates a profit. Product 2 for Samsung, and likewise the profit 2 indicates profit or loss for that product. If you look at this, perhaps you can turn this into time series modeling or time series forecasting. One thing to note and duly highlighted is Sunday. Sunday looks like the store is closed, this arbitrary company X. So first of all, you need to decide, what are you doing? What are you trying to forecast here? Are you trying to forecast the entire company's sales? Or are you trying to forecast the Samsung or Apple? That makes a big difference. You also need to create a time index. In other words, yes, of course, you can do it by day, but if Sunday is always going to be closed, it's always going to show a 0. Not necessarily a good thing. Think about all the stock market stocks. All of them are closed Sunday and Saturday. So if we look at the chart, if you plot the chart, it's always going to see flat line on those days. That's probably not useful. So once again, decide if you're trying to predict or forecast the total profit or by product, Samsung or Apple. And it is always an excellent idea to remove days that you know are going to be closed. Stat holiday is another one, right? If you want to know and if you want to ensure the data takes into account of the days when it's going to be closed, that's going to be a good thing. Or else your model will always going to be having some sort of issues. So how do we go about this? Let's look at this example here. We can split this into total sales. So what we did here is we re-indexed. As opposed to 25 entries, now we're doing more down to 21 entries. Index 1 corresponds to Monday, and the Sunday is taken out. So when we plot a chart, we see a continuous plot. So first day when the company was in business, the total profit was $37,000 or dollars, whatever you want to call it. That is summation or sum of Apple and Samsung product. So if you wanted this time series data on the right, could be excellent forecasting data set for you to predict the forecast for the 28th day of the company being open, or 25th. So you can historically go in there. You can also find seasonality, trend, and cycle given this data, which I'll cover in the coming up videos. Let's say you want to just do for Apple. Well, same thing. You will eliminate the Samsung component of it. So you'll just reorder, re-index the time, and the key would be Apple here. Same thing with Samsung here, right? The Samsung looks like it has a lot of positive sales. So likewise, you can do a bunch of things. So once again, once you have a time series data, or once you think you have a time series data, ensure it has a temporal order, it is equally spaced or has equal intervals, and you decide what you want to do. But I must caution that forecasts are never perfect. Although with a lot of data, we might be getting close. It is not, you're never going to be able to perfectly predict tomorrow's weather. Perhaps the takeaway here is we can probably go a little close. Many factors, unpredictability, human behaviors when it comes to sales and marketing. But having a lot of different data allows your forecast to get closer and closer to the real data. And you hope that it actually adds value. Hence, proceed with forecasting when you have a lot of data, and proceed with forecasting when you know the factors really well. Thank you.